Okay guys, today we've got section 4. We're still in chapter 1. We are going to talk about coterminal and quadrantal angles today. So these are two vocab words. I've got some stuff written out here for you. First of all, negative angles. I told you a couple days ago we were going to start talking about negative angles. Negative angles go backwards. And that is pretty much it. Class dismissed. Just kidding. You know how, for example, if I'm going to graph 30 degrees, pretend this is positive 30. Then we talked about how this first dot here represents 30. You always start on the positive x-axis and you rotate. This is actually counterclockwise. So you go 0, 90, 180, 270, 360, and you go this direction. If it's negative, you go backwards. You still start at the positive x-axis, but negative 30 means go backwards 30 degrees, so it's actually right here. It's symmetric with positive 30. Negative 30 is down here. It's the same exact starting point, but you move backwards. So this says the first thing, well, I should go over the vocab word first, I guess. A negative angle rotates around the unit circle in a clockwise direction, that's backwards, starting from the positive x-axis. And so, always starting from positive x-axis, I'm just going to label these on my graph. So for negative 30 degrees, we're going to go backwards 30 degrees, and I'm going to label it right here. That's point A, starting at the positive x-axis, going backwards 30 degrees. Negative 75 degrees, again, we're starting at the positive x-axis and we're going this direction, not all the way to 90, but past 60. You know, this dot represents 60 degrees, negative 60. So in that case, somewhere in here is where B is, negative 75 degrees. Not quite to 90 degrees, but almost there, somewhere between 60 and 90. Letter C is negative 90 degrees. So again, starting at the positive x-axis, going backwards, we're right here. So point C, there. D is negative 150, so not quite to 180 degrees, a little bit short, 30 degrees short, we're right here. So if you can kind of count from 0, this is 90, plus 30 is 120, plus 15 is 135, plus another 15 is 150. So you can actually do the math there. It is one of those dots, 150. It is 30 degrees shy of 180 degrees. So this is D. Next one, E, negative 180. So starting at the positive x-axis and backwards 180 degrees, we're right here. So here is our ending point, and that is where I'm going to put point E. And then the last one, 200. So 200 degrees is somewhere between 180 and 270, and again, it's negative, so we're going backwards. It's not one of these dots, though. This very first one is 30 degrees away from 180, so that would be 210. So I'm just going to stop a little bit short here, and I'm going to put an F right there. That is negative 200 degrees. Remember, starting here, 90, 180, a little bit past, but not quite to that first dot. So that's how you do negative angles, you guys. And now we have coterminal angles, and those are angles whose measures differ by 360 degrees. So coterminal, do you remember that terminal means ending? And so coterminal means they end in the same place, but you're just going around the circle multiple times. So remember how we talked about this is 0 degrees, and instead of going backwards, let's say I'll go forwards. Let's say I'm talking about 360 degrees. So here's 0, going all the way around the circle, one complete rotation puts me back in the same exact spot, which is 360 degrees. What if I wanted to go around the circle again? Another 360 degrees. That would be 720 degrees, but it's still the same ending location. This line right here, this dot represents 0, 360, 720. You can keep going around and around and around and ending in the same place, and all of those represent different degree measures. So I want to give you one example here to begin. 30 and 390. Do you know what 30 degrees looks like? I'm going to rotate up 30 degrees. There's what 30 degrees looks like. In a different color, I'm going to do 390 degrees. So starting here, going all the way around and ending in the same exact location. This represents 390 degrees. They are coterminal, my friends, because they end in the same exact place. You'll notice that these have a difference of 360 degrees. Okay, and that's kind of in the definition up here that I kind of breezed over. The angles whose measures differ by 360. An angle and its coterminal, so same ending spot angles, all have the same initial and terminal sides. The only difference is sometimes you rotate around the circle more than once. However, they begin and end in the same place. So let's talk about 125 and 485. Notice how those also differ by 360 degrees. 50 and negative 310. Let me draw this one. There's always an image or a picture that goes with all these all these examples. So 50 degrees is somewhere here in the first quadrant. 50 degrees. It is between 0 and 90, obviously. Negative 310. Remember that negative degree? That means go backwards. So if I go backwards 310 degrees, how far away from 360 is that? It's exactly 50 degrees shy. So it does appear as though I ended in the same exact location. So you can sketch these. Just remember that we're going actually counterclockwise for positive angles, and we start at 0, but we go backwards for negative angles. So there's an image that goes with all of those. And the difference between these two angles is, again, 360 degrees. So let's see. Using negative angles listed above, see if I can find the smallest positive coterminal angle for each. So remember the difference is 360 degrees. So for all of these negative angles, to figure out what they are in positive language, it's very simple. All you do is you add 360. So in this case, we get 330 degrees. Remember, coterminal means same ending position. I'm going to draw a sketch for this, just so it makes sense. Negative 30, what does that look like? Start at the positive x-axis and go backwards 30 degrees. This is negative 30 degrees. Would you agree that that is the same exact thing as starting with the positive direction but rotating this way 330 degrees? Notice how they end in the same exact location. All you have to do is add 360 to those. Here's another one. Negative 75 degrees, I'm going to add 360 to it. And that gives me, what, 285? Cool. That means if you go backwards 75 degrees, it's the same exact starting and ending position as if you go forwards 285 degrees. Negative 90, again, you add 360 to that, and I end up with 270 degrees. Let me sketch that one real quick, just since it's simple to sketch. There's negative 90 degrees, you end right there. If I go positive 270 degrees, we end in the same exact location. That is called coterminal angles. Let's do a couple more. Negative 150. Again, we're adding 360 to it. We get 210 degrees. What does that look like? Negative 150. Looks like that. I went backwards past 90, not quite to 180. If I add 360 to that, I end up with positive a little bit more than 180. That's 210 degrees. You don't have to have these sketches to go with your answer. I just want to explain why this is not, again, I harp on this all the time, we're not just memorizing stuff and being robots. We're actually understanding what it is that we're talking about. And there's an image or a picture or a sketch that goes with all of them. Okay, so another example, let's see, negative 180 degrees. So again, what I'm going to do is add 360 to that, and I get 180 degrees. What does that look like? You should kind of have an idea in your head. Negative 180 is here. Positive 180 is here. They end in the same exact location. No big deal. Last one, negative 200. If you're adding 360 to that, you get 160 degrees. So again, just a sketch. Negative 200 is somewhere in the third quadrant, like so. And if you go positive 160, you end up in the same place. So that's that. Let's talk about quadrantal angles. These are angles whose terminal sides, meaning they end on either the x-axis or the y-axis. So we are talking about an angle that starts and ends here, that's 0 degrees or 360. What about an angle that starts or ends right here on the y-axis? So that's an ordered pair that we've talked about in the past. Here's another one, here's another one. These are called quadrantal angles. Here's what they are. 0, 90, 180, 270, 360. Complete the table with the 6 trig functions for each quadrantal angle. This is not a table to memorize. This is a table that you're going to think your way through. Way too much stuff to memorize in trig. You guys don't memorize tables like this. 0/360. As you know, that's in the same exact location. They're both right there. 0 degrees represents you haven't rotated at all. 360 degrees represents you've gone around the circle an entire time. What is that ordered pair? That ordered pair, something, comma, something. I believe we went right. This is unit circle stuff. So we went right 1 unit. We went up or down 0 units. Okay. So now let's see if we can figure out what the sine of theta at 0 degrees is. Remember that sine is y over r. So what is the y value at 0 degrees? 0. What is the r value always on the unit circle? No matter what, the radius is always 1. 0 divided by 1 is 0. Therefore, the sine of 0 degrees, or 360, either one, is 0. Let's try another one. Let's do cosine. Remember that that is x over r. So again, remember the r is always 1 because it's the radius. What's the x value of that ordered pair? X value is 1. At 0 degrees, the x value is 1. 1 over 1 is 1. I'm going to continue completing the table like so. What about tangent? Remember that one is y over x. So what is the y value of this ordered pair? 0. The x value, 1. 0 divided by 1 is 0. Cool. Now can you flip all these things? Remember that sine is the reciprocal of cosecant. So if I flip this fraction, is it still 0? No. Very, very careful. In trig, the difference between 0 and undefined is extremely important. Do not flip those up. If the 0 is on top, you can actually do this in your calculator. What's 0 divided by anything? Your calculator will give you 0. What if in your calculator you do 1 over 0? It's going to give you an error. That means undefined. Do not leave your answer like this. Actually say undefined. This is the correct answer, and this is the way that you're supposed to write it. You can remember the undefined. Und is kind of like under. The 0 is under the fraction. The 0 is underneath. So some people, when you're first learning what undefined is, I learned it as underfined. Get it? Because the 0 is in the bottom of the fraction. So that is how you remember undefined. Remember that cosine goes with secant. So if you flip 1 over 1, you still get 1. So I'm going to go ahead and write that. And same thing for cotangent. We are going to flip the tangent. So if I flip this fraction upside down, do the reciprocal, that gives you cotangent. So again, 1 over 0, that one is undefined. We're actually going to have a lot of undefineds and stuff in this chart. So just beware of that, but always write undefined. Don't leave it as a fraction with 0 in the denominator. Just go ahead and say undefined. We're going to be using that a lot this semester. Let's talk about 90 degrees. So the next column, or the next row, 90 degrees is right here. We rotated from 0 to 90 degrees. Do you remember what that ordered pair is? I believe we went left and right 0 and up 1 unit. Again, we're talking unit circle stuff. So again, let's do the sine, which is y over r, of this ordered pair. In this case, the y value is 1. The r is 1. That gives us 1. Cosine is x over r. So x over r, the x value of this ordered pair is 0. The r is always 1. Yes, you'll see some similarities and some patterns here as we kind of work our way through. We'll talk more about that in class, but tangent y over x. So the y value is 1, the x value is 0. That means undefined. And now let's flip some of these. So remember sine, the reciprocal is cosecant. So if I flip this, I still get 1 over 1, which is 1. For secant, if I flip the cosine, I get 1 over 0, which is undefined. And the last one, if I flip the tangent, I get 0 over 1, that is 0. check it in your calculator. 0 divided by anything is 0, but if you put 0 in the denominator, the underneath part, it is undefined. Can't stress that enough. That's a really important thing in trig to make sure you've got straight. Okay, 2 more rows. 180 degrees, that means I'm over here now. That ordered pair is -1, 0, and 270 is down here. That ordered pair is 0, -1. I dare you to pause the video and see if you can fill in the bottom 2 rows from this chart. And then I am going to pause, fill it in, and then I'll briefly talk through it really quickly so that you can check your answers. All right, you guys, so here are the bottom 2 rows filled in for this table. So I'll just go through these kind of quickly. We had already graphed our ordered pairs and talked about this point being -1, 0, and this point 0, -1. So remember, just sine is y over r, so the y value here is 0, the r is 1, 0 divided by 1 is 0. You don't have to write out these fractions every time. It helps me to think through, but honestly, what I'm concerned with is knowing that the sine of 180 is 0 degrees. And the cosine of 180 is -1. So just be really closely careful with all of your negative signs in this case, because we have ordered pairs in on this axis and on this axis that are negative. That made some of our trig functions or trig ratios negative, so just keep that in mind. And also, again, for like the millionth time, just be really careful about the difference between 0 and undefined. So go ahead and check those out, copy those down, make sure you're okay with those. Bring your questions to class tomorrow. Thanks for watching. Hey, you guys are doing a great job. Keep it up. We're doing this.